Hello friends, welcome to Mathematics Scolio. In this video, we will discuss one application of Wilson's theorem. So here is the question. It is given that 1 plus 1 by 2 plus 1 by 3 up to 1 by 23 is equals to n by 23 factorial. Where n is a natural number, what is remainder when n is divided by 13? So we have to find remainder when n is divided by 13. And from where we can calculate n? For that, this relation is given. In this relation, if we find n will be equals to, you can check that 23 factorial we have to cross multiply, and we will get 23 factorial plus 23 factorial upon 2 plus 23 factorial upon 3, so on up to 23 factorial upon 23, which we can write in the form of summation r is from 1 to 23 and 23 factorial upon r. This is value of n. We have to find remainder when n is divided by 13. Now, in these 23 terms, there is only one term which is not divisible by 13. Rest of all terms are divisible by 13. Which is that term? That is 23 factorial upon 13. So we can write that this is congruent to 23 factorial upon 13. All right, which is same as 12 factorial into pi. R is from 14 to 23, r modulo 13. So our question reduces to we have to find remainder when 12 factorial into pi r from 14 to 23 r modulo 13, when 12 factorial into pi from r 14 to 23 r is divided by 13. This is our problem now. Okay. Now there is a claim that I'm writing one claim. What is claim? That pi r from 14 to 23 r is congruent to 10 factorial modulo 13. All right. We can take this equation as equation number 1. So this is our claim. Let's prove it first. As you know that 14, just a minute, let's prove it first. As you know that 14 is congruent to 1 modulo 13. Similarly, 15 is congruent to 2 modulo 13, and so on. 23 is congruent to 10 modulo 13. And we know one property. What is that? If A is congruent to B modulo n and C is congruent to D modulo n, this implies that AC is congruent to BD modulo n. By using this property, we can say, means we have to multiply left hand sides. We can say that pi r from 1 to 14 of r is congruent to 10 factorial modulo 13. All right, this is the result which we are getting. So our claim is true. Now from 1 we can say our claim is true. Now from 1 is this. Okay, from 1 we can say, and I'm taking this as 2, this claim as 2. From 1 and 2, we can say that n is congruent to 12 factorial into 10 factorial modulo 13. Okay. Let this equation be equation number 3. Now, as we know Wilson's theorem, for some prime number k. What is Wilson's theorem? For some prime number k, k minus 1 factorial is congruent to minus 1 modulo k. So 13 is prime number. We can apply Wilson theorem in 13. So it is 13 minus 1, that is 12 factorial, is congruent to minus 1 mod 13. 12 factorial is congruent to minus 1 mod 13. But we have to find n is congruent to 12 factorial into 10 factorial. So we have to calculate 12 factorial into 10 factorial congruent to dash modulo 13. That is what we have to calculate, or we can say we have to calculate what is remainder when 12 factorial into 10 factorial is divided by 13. As you know, if we divide 12 factorial with 13, we are getting remainder minus 1, but we don't know about 10 factorial. For 10 factorial, simplify this. 12 factorial, we can write 12 into 11 into 10 factorial, congruent to minus 1 modulo 13. All right. Which we can write minus 1 congruent to 12 into 11 into 10 factorial, congruent to 12 means minus 1, 11 means minus 2. So we can write here minus 1 into minus 2 into 10 factorial modulo 13. Minus 1 also we can replace. All right. We are getting minus 1 congruent to 2 into 10 factorial modulo 13. And minus 1, you can replace minus 1. Just a minute. Here I am writing 2 into 10 factorial is congruent to minus 1 modulo 13, and minus 1 you can replace with 14. You can replace with 12 modulo 13. Why? Because 12 is congruent to minus 1 modulo 13. Okay, so this is what we are getting. 13 is a prime number, so we can write 10 factorial is congruent to 6 modulo 13. 10 factorial is congruent to 6 modulo 13. Now come to this equation. I'm naming this equation as this is equation number 3. I'm naming this equation as 4, and I'm naming this equation as 5. So we can conclude that from 4 and 5, from 4 and 5, 4 is, this one is 4, 12 factorial is congruent to minus 1 modulo 13. From 4 and 5, we can say that 12 factorial into 10 factorial is congruent to minus 6 modulo 13, which is same as congruent to 7 modulo 13. So as you know, n is congruent to 12 factorial, 10 factorial, congruent to minus 6 modulo 13, congruent to 7 modulo 13. Therefore remainder when n is divided by 13 is 7. So this is our answer. Okay, hope you enjoyed this video. Please like and share the video and subscribe the channel. Bye bye for now. See you in the next video.